Next on scientific notation. So I went home and did yard work yesterday. Okay. I got a party tonight at my house. The whole football team's eating in my house tonight, so I had to get the yard work away, so it worked out good. You know what I mean, though? You didn't volunteer to come help weed eat or anything. My bad. That's a good response. I like that. All right. Does anybody know what scientific notation is? You've probably seen it somewhere. It looks like this. 5.4 times 10 to the 6th power. That is what scientific notation looks like. Does anybody know the purpose of it? Why did they invent scientific notation? Just to punish students? Is that the goal? Yes. No, it's not. You think it is, but it isn't. Scientific notation is a way to write very big or small numbers. It's kind of like a shortcut. So, this is actually a pretty big number. Here it is. This number is 5.4 million is the real number that this represents. Are you with me? We're going to talk about how to get from there to there today. All right, so, and like the distance from here to the sun is like a huge number. Are you with me? It's a lot of miles away. Or even here to the moon, when we went to the moon. The moon is, I need to look it up. We'll look it up in a minute. Bless you. Keep it covered, please. So scientific notation is a way to write really big numbers or very tiny numbers. Like if we tried to measure one of your DNA molecules, it would probably be something like this. 0.0000. Inches. Are you with me? It's a very tiny number. You'd have to have a very high-powered microscope to look at it. Does that make sense? My old eyeballs can't see one of your DNA molecules, but a microscope can. So scientific notation is for really small numbers or very big numbers. Are you with me? All right. Let's take a number and let's write it in scientific notation. Let's start with the distance to the moon. I'm just making this up. Let's pretend it's this number right here. Write it down. Now, I really don't feel like writing out all those zeros, so let's make this into a scientific notation. All right, here's the first rule. We're going to put a decimal after the first non-zero number from the left. Okay, here's two key words. The first number that is not zero from the left. So let's all look at this. Start over here at the left. Is this number not a zero?
Yes.
Yes. That's the first number that's not zero from the left. According to that rule, we're going to put a decimal right after that. So I'm going to erase this, and we're going to put the decimal right here between the 1 and 2. Sweet. Now, I'm going to go ahead and write part of my final answer. 1.2. Once you put the decimal in, then that's the numbers you're going to put. We're always going to put times 10. And then we're going to put a little power up here. And I'll tell you how to figure out what number goes up there for the power. Step 2. Count from your new decimal back to the old one. Now, first of all, before we start counting, here's my new decimal. You'll agree? Mm-hmm. That's the one we just put in. Where in the heck is the old decimal in this really big number? Where was the decimal at the... Yeah, if it's not in sight, it's to the
right.
To the right. Not in sight, it's to the right. So we didn't see a decimal in the beginning, so the original decimal was way over here at the right side. So now we're going to count from this one to this one. Let's start counting. Every time you pass a number, let's count. Together, please.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Very nice. You'll stay on cue perfectly. How many times did we count?
12.
12. There's a little 12 that goes right there. And this is the scientific notation from the distance from here to the moon. Questions so far? So we count from the new decimal to the old. If there's no decimal inside it, is to the right. Keep all this in mind. Are you with me? All right, let's do another one. Let's take the mileage on my truck. I just looked at it yesterday. This is pretty close to the mileage on my pickup truck. All right, we're going to put in the new decimal. It goes after the first number from the left that is not 0. What is the first number?
1.
1. Do y'all all agree? It's 1. So the decimal goes right here after the 1. There's the new one. Where's the old one? It's over here to the right. So let's count. Oh, by the way, go ahead. Once you put the new decimal in, go ahead and write your decimal, 1.5. And if there's any other numbers, you need to put them all. 1.52432. Now let's count.
1, 2, 3, 4, 5.
This one is going to be times 10 to the 5th power. Questions? Somebody. All right, so it's really not that hard. You just got to put in the decimal where it needs to go, and then you just need to count from the new decimal back to the old. Thank you, ma'am. Hopefully it's full of money. Yeah. Okay. Times 10. That's a great question. Times 10. Let's talk about that. If I do 1 times 10, what do we get?
10.
What if I do 1 times 10 to the second? 100. Do you notice what happens every time I make the number? By the way, this is really 10 to the first. Every time I make the power bigger, we add another
0.
Do you now understand why it's a power of 10?
Yeah.
Great question, Gabby. If I do 1 times 10 to the third,
1,000.
that would be 1,000. Every time I make 10 go up a number, that moves the decimal or adds another 0 in the problem. Great question. Any others?
No, sir.
All right, let's do a small number now. 0.0000036. Let's say they give me this tiny number, 0.00036, and they want me to write it in scientific notation. Let's put in our new decimal. Is this a non-zero number?
No.
Nope.
No. Yes.
There's the first number from the left that is not 0, so where does my decimal go?
Right there.
In between what?
3 and 6.
In between the 3 and the 6. Good. It doesn't go here, it goes here. So here's the new decimal now. And here's, the old one was already there. Are you with me? I didn't have to put it in because it was right there. So, I'm going to write the decimal 3.6 times 10. Now let's count.
1, 2, 3, 4, 5.
Now this time, we went to the left, didn't we?
Yeah.
Well, it can't be the same number while ago as I was counting to the right.
Negative.
Yes.
Oh.
If you go to the left, make the 5 negative 5.
Oh.
So, let's put a little note. If you count to the right, it's a positive exponent. If you count to the left, it's always going to be a negative exponent, like we just put, negative 5. So the big numbers are going to be positives here. The little tiny decimals are going to have a negative there. Question so far?
Okay.
Let's do one more. Let's do an easy one. 0.08. Where is my decimal gonna go? After the 8. You'll agree? Because from the left, 8 is the first number that's not 0. So put the decimal here. So here's new, here's old. Let's count backwards.
1, 2.
So we're gonna put 8.0, because there's not another number after the 8, times 10 to the what?
Negative 2.
Negative
2.
2. Sometimes we only have to count a few numbers. Sometimes we got to count a bunch. 8, 9, 10, whatever. Questions so far?
No, sir.
All right, the next thing you're going to have to do on the homework today is they are going to give you a, yes?
Can you ever count from the old to new?
No, you'll get every problem wrong. You want to go from new to old. That's a great question. She goes, what if I count from old to new? You're going to be putting positive when the answer should be negative. Or you're going to have a negative when the answer should be a positive. Go from new to old every time. Good. They're going to give you a problem in scientific notation, and you are going to have to write the new number or the real number. What's not hard? Step 1, write the decimal, 9.4. And since this is positive 4, do you think we're going to go to the right or to the left?
To the right.
Positive goes to the right. So I'm going to start counting 4 to the right. Let's count.
1, 2, 3, 4.
Here is where the decimal now goes. What do I need to put in those blanks? Zeros. And now let's rewrite the final answer. It is 94,000. That's not a 6. Okay, questions? Let's do one with the negative. I'm going to take the same problem, and I'm just going to make that negative 4. So let's write the decimal again, 9.4. Since it is negative this time, let's go to the left. So count with me.
1, 2, 3, 4.
Here is where the new decimal goes. Are you with me?
Mm-hmm.
And what do I put in here?
0.
So I'm going to write my final answer now. Don't leave your answer like this with all the loops on it on the homework. Are you with me? Rewrite it. 0.00094. That would be the correct answer for that. Okay, questions? Scientific notation isn't that difficult once you understand the negatives go to the left, the positives go to the right. If there's no decimal in sight, it's to the right. Any questions? All right, you're ready for the homework.